if we look at the circle as the set of all points that are a given distance from a fixed point. And there's a slight flaw to this definition. Can anybody catch what that flaw is? PJ? Yes, so this definition that I wrote up here is actually the definition for a sphere. So what limits it to a circle? Yeah, they have to be on the same plane. So we do need to add this term, this descriptive term, coplanar points. Okay, so a circle is defined as the set of all coplanar points that are a given distance. Okay, when we look at this given distance is called the radius. Okay, so here would be our given distance from a fixed point, and our fixed point is called a center. Okay, so that is how we define a circle. It's a set of all coplanar points, a given distance, the radius, from a fixed point, the center. All right, so in looking at this circle here, we have a center, we have a radius. As far as the location of, or actually let's talk about naming the circle. And so we can name a circle by its center. And so we can call this circle A. And now the one time that we can't name a circle by its center is if that circle, or if that center is the center for multiple circles. And those would be called concentric circles. So this set down here, or any set of circles that have that share the same center, would be considered concentric circles. So these four circles down here, you can't name them circle B because you don't know which particular circle you're talking about. And so the other way to name a circle is by choosing 3 points that lie on the circle itself. So we could also call this circle CDE. And so if we look at how points can be located with respect to a circle, we can say that points are located in the interior of a circle. So the center is included in that. So the center of a circle is not considered a point on that circle. It's just a point to help define the circle. It's that fixed point from which the distance is the same. Okay, but so all of these points inside the circle would be considered the interior points. Okay, we also have a set of exterior points. So all the points that fall outside but not on a circle would be considered to be in the exterior. And then we have the set of points that fall on a circle. So the points that fall on a circle are the points that fit the description of that definition of circle. It's the set of all coplanar points that are that given distance from the fixed point. Right? And so if you measure this distance around where the points that are on the circle, that's called the circumference. And so the circumference is basically it's the perimeter of a circle, or its boundary. And the circumference is measured, is identified with a capital C, and it's measured as twice times, or 2 times pi times r. 2 pi r is the measure for your circumference, and where r is the radius. And now, if what we found in the earlier chapter is if we wrote or drew 2 radii, which is the plural for radius, back to back so that they fell in a same straight line, they actually create what's called a diameter. And since the diameter given by d is equal to twice the radius, 2r, we could also say that the circumference is, and if we replace 2r with a d, we get what's really the original equation for circumference. Circumference is equal to d pi or 2 pi r. Right? And actually, pi itself is defined as the ratio between the circumference of a circle and its diameter. And that is actually how pi is created, or the value of it is obtained. Right? So those are some formulas and relationships that you should be, again, familiar with already, but just to review really quickly. Okay. All right, anybody need me to stay on this slide any longer? That's good. All right, so let's talk about some of the parts of a circle. This is in your book, so you don't have to specifically write all of these out. Okay, it's on page 64. Okay, I just want to talk through some of these I already mentioned. Okay, first, the center. The center of a circle is that coplanar point that's equidistant from all the points on the circle. So any point along the circle is the same distance from the center. And that distance is called the radius, or the segment connecting those is the radius. So the radius of a circle, again, the radius is identified as a segment whose endpoints are the center of a circle and a point on the circle itself. If you draw in two radii in the same straight line, you create the diameter. The diameter is a chord that passes through the center. Its equation, given by the equation, diameter is equal to twice the radius. And now I define it as a chord, so let's talk about chord really quickly. A chord is a segment whose endpoints are both on the circle itself. So a radius has one endpoint on the circle, one endpoint at the center. A chord is going to have both of its endpoints on the circle itself. And then the final thing that is set up when you identify the portion of a circumference that's contained between 2 points on a circle is called an arc. So if we looked at this measure, I'll talk a little bit more about about arcs here in just a little bit. But an arc is a portion of a circle's circumference or perimeter that's contained along this circle's circumference. Okay, so this brings us to the last two things I want to talk about, and that is elements that intersect a circle but then extend beyond it. The element that intersects a circle at one and only one location is called a tangent. So this is an example of a tangent. It's a line that intersects a circle at exactly one point. Okay, so now if I took this line right here, in the drawing that I have, there's only one single intersection, but if you extend this line infinitely, will this intersect the circle a second time? Yeah, so it's not considered a tangent. A tangent is a line or a portion of a line that intersects a circle at exactly one point. Okay? Now, there's a distinction that needs to be made between tangent, the word tangent used as a noun, and then the word tangent that's used as a descriptor or an adjective. Right? If you're talking about a tangent is this line that intersects a circle at one point. If you're talking about something being tangent, so a segment can be tangent, a chord can be tangent, or a line can be tangent, a ray can be tangent, another circle or a triangle, some other figures, those can all be tangent to a circle. So that describes a relationship. And so when you're dealing with tangent as a descriptive word, that element simply needs to be a portion of an actual tangent line. So a tangent segment, so if I had a segment that intersects a circle at one point, this is not considered tangent because it's not part of a tangent line. Whereas if I had this tangent segment from here to here, if it was part of an actual tangent line, then that would be considered your tangent segment. Okay, so you can still use tangent as a descriptor as well. And now, in these cases where we extend it through and we have an element or a line that intersects a circle at two locations, so here and here, let's say, then we have what's called a secant. A secant is a line that intersects a circle in exactly two locations. All right? Questions on those parts?
So if you could draw it like as a tangent line, then you could describe it
Yeah, so if it's a part of, so if you have, let's say, a ray, if that ray is a portion of an actual tangent, a line that intersects, then the ray would be considered tangent as well. So if we extended this through and it was part of a single tangent, then that would be considered a tangent ray, or a ray that is tangent. All right, what I want you to do is just take a couple minutes here, see if you can answer these 6 questions.